Okay, Assalamu alaikum. Last time we started chapter number 12 in dynamics, and before continuing further, I need to ask anybody has any question. I uploaded all the material on a Google Drive link, and I put the Google Drive link in the announcement on the blackboard. I hope everybody have received it and downloaded all the material. You had the book, then you have all the lectures, as well as there are some supplementary material which I also added there. The supplementary material are my handwritten notes. So anybody who is not able to download the material, you can ask me. Anything anybody want to ask regarding the previous lecture? Okay, so I guess I can continue forward. You're able to hear me properly, right?
Yes, we can.
Okay. I need to keep asking this question because sometimes I don't really know whether you're hearing me or not. So, anyways, so let's continue onward. We were studying. We developed 10 most important equations last time in our lecture, and we solved some of the problem. We are going to continue forward. Let's discuss about the next topic: rectilinear kinematics, erratic motion. Now, erratic motion is basically what? Erratic motion is basically kind of motion where the motion is not following a specific sequence. I mean, there, there is variation within the motion. For example, normally if I go to, if I go from car to somewhere, so what will happen? Initially, my car is stationary. I'm going to turn on my car. Then I'm going to start from rest. So the car will start from rest initially. Let's say if I'm on a steady road, so there will be some acceleration, and after that, my car will become uh, at a, at a speed I want to. Let's say I move on to the speed limit, and then after that, I remain with the same within the same speed limit. So initially there will be acceleration. After that, acceleration will become zero, and so it's like a similar problem that we did last time. The last problem that we did. So this is how things are in reality. Sometimes the complete motion cannot be presented by a single state of equation. So you need multiple equations from multiple stages of the motion. That kind of motion is known as erratic motion. So for example, here this truck, it started from zero velocity, and then its velocity kept on increasing at a specific rate, and so the velocity could be written in as a function of distance. Uh, After that, after a certain distance has been reached, then for the remaining distance, the velocity remains constant. So now this motion is an erratic motion because it cannot be defined by a single equation. We need to divide it into multiple steps, into multiple stages. And then for each stage, you can have a single equation, but the whole motion from start to the end cannot be put in a single equation. So that kind of motion is known as an erratic motion. So our last problem which we solved was basically an example of erratic motion because we had two cars. If you remember, we had car A and car B. The car B was moving with a specific velocity with no acceleration. So the whole motion of car B was not erratic. The whole motion of car B could be represented by a single equation. However, for the car A, initially the car A started from rest and it has a certain acceleration, 6 feet per second square. However, after it reaches a certain speed, then the acceleration becomes zero and it maintains the speed. So for car A, there were two sections, two stages of motion, and each stage could have a single set of equation. You cannot have one set of equation for both stages of car A. So this was an example. The motion of car A was an example of erratic motion. Motion of car B was okay. That doesn't count into an erratic motion because it was just one stage of motion. So anyways, this is an example of erratic motion. So you do understand now what is an erratic motion. Whenever you have a motion such that the motion cannot be described from the start to the beginning in one set of equations, and you need separate set of equations for separate sections of the motion, then that kind of motion is known as erratic motion. Is it clear? Okay, good. So let's discuss erratic motion. Now, whenever we have erratic motion, we can define the erratic motion through graphs. So we can have ST graph, we can have VT graph, we can have AT graphs. ST means position, displacement versus time, velocity versus time, acceleration versus time, and other set of graphs we can have. So let's have a problem associated with it. The bicycle moves along a straight road such that its position is described by the graph shown in the figure. So we have this problem that we have a bicycle which was moving on a straight road, and its position is represented by a graph on the figure. So from time 0 to 10, from time 0 to 10 second, the motion was represented by this equation. S is equals to t square. For for time 10 second to 30 second, the motion is represented by this equation. S is equals to 20t minus 100. Now, this is basically what? This is ST graph. This is given in the question. Now, what is required? Construct the VT graph and the AT graph for this time range, 0 to 30 seconds. This is 0 to 30 seconds. Okay. So before solving the question, first of all, do you understand the problem statement? We have the motion of the bicycle, which can be defined in two stages, from 0 to 10 second, 10 to 30 second, and it is presented in the form of an ST graph. This is given in the question. What is asked? Draw the VT graph and AT graph. So do you understand the problem statement or not? Okay, good. So let's move ahead. So now if you understand the problem statement, let's move on to the solution. Solution is very simple. What is the relationship between S and V? We need to find VT graph. We have ST graph. So what is the relationship between S and V if we have given S as a function of time? So this is basically what? S is equals to V equals to ds by dt. We just differentiated with respect to time. If I differentiate this with respect to time, what will be the velocity? It will be 2t, right? If I differentiate this with respect to time, what will be the velocity? It will be 20. Okay. So now I know the velocity equations for both the regions. So for the first region, 2t, so it's a function of time. When time 0, velocity will be 0. When time 10 second, velocity will be, uh, if I put here 10, so 2 multiplied by 10, 20. So this will be 20. And it is an equation of a straight line. So velocity will be straight line like this. Okay. And after that, for the second part, it's not a function of time, 20 constant. So it will remain 20 constant. So that will be the graph VT. Let me show this graph to you guys. So you see here, this is the graph VT. So let me just put it here. Okay. See here? From the initial equation will be V equals to 2t. That for the next equation will be V equals to 20. So 2t means when t is equals to 0, velocity is 0. When t equals to 10, velocity will be 20. So now this is the VT graph. As simple as that. Your first part of the question is done. Do you understand it or not? Anybody who do not understand how this graph is drawn, please ask. Good. It seems everybody understood. Actually, it's not difficult. It's simple. So now we need to draw the AT graph. How will we draw the AT graph? Just differentiate again with respect to time. So when you differentiate velocity with respect to time, it's a constant. So what will be A? A will be 0. When you differentiate with respect to time, this will become 0. And when you differentiate this with respect to time, so A will be 2. So constant. So from 0 to 10 seconds, it will be 2. And then from 10 to 30 seconds, it will be 0. So let's see this thing here. Look at here. 0 to 10 seconds, it will be 2. Then 10 to 30 seconds, it is 0. So I've drawn the AT graph. That was needed in the question. Draw the VT graph, AT graph. We have drawn the VT graph, we have drawn the AT graph. The value here will be 2. The value here will be from 0 to 20, and then 20 will become constant. And this is what all written here, what I've shown you done in the graph. So the question is complete, it's done. Do you understand the solution? Is there anything that you do not understand? Please ask. Okay, good. The question is easy. It wasn't that difficult. Okay, let's move ahead. We can also have VT graphs. Okay, let's see this one. The VT graph is given. Now in the question, what is given is VT graph. So here we have V, here we have T. So VT graph is given in the question. Now what we need to find AT graph and average speed and the distance traveled for 0 to 90 seconds. So this is 0 to 90 seconds. We need to find speed and distance traveled. So now for one thing, we need to move one way forward. For the other thing, we need to move one move backward. When we need to find AT graph from VT, so we have to just differentiate it once again. But when we have to find the ST graph, because we need to find average speed and average distance traveled. So that means now we need to integrate. Okay, from velocity to acceleration, you have to differentiate. From velocity back to the speed, or from velocity back to the distance, you need to integrate. So differentiation one time integration. Okay, so let's see how it's done. For differentiation, it's very simple. V equals to T. So A will be what? A will be 1 if you differentiate it with respect to time. And here V equals to negative 0.5 T plus 45. So A will be what? A will be negative 0.5. So two constants. So let's have a look at it. You see here, from 0 to 30 second, and then 30 to 90 second. From 0 to 30 second, it's 1. Then from 30 to 90 second, it's 0.5. Is it clear? So one part of the question is done, where you need to have the AT graph using the VT graph. Now let's discuss about the second part of the question. In second part of the question, you need to integrate, because now you need to move towards the ST, but the graph is not needed. What is needed is that just find the distance. Okay, so how do we integrate? So we have the basic equations. Let's come over to the basic equation. So we have the basic equation is what? S will be integral V dt, but you have to apply the limit. Limit will be what? 0 to 30, right? And then for the second stage, again, S will be V dt, but apply the limit from 30 to 90. You have the equation for both the case. Okay. For the first case, what is the equation? For the first case, the equation is V equals to T. So just substitute T. Okay. So if I just substitute t, so t dt, if I integrate t dt, what it will become? T square upon 2, and the limit is from 0 to 30, it will be half t square equals to 450 meter. And for the second part, I have negative 0.5 t plus 45. So if I just substitute here, negative 0.5 t plus 45, so it will become what? Negative 0.5 t square upon 2 plus 45 t. So this will be the, so this will be when I apply t as 90, minus this will be when I apply t as 30, when I apply the limits. So substitute the values, you will get delta S. So the total delta S will be the region traveled from 0 to 30 and the region traveled from 30 to 90. So that will be 450 plus 900, that is will be 1350. And the average velocity will be the total distance divided by the total time, which will be 15 meter per second. I'm going to wait here 5 minutes, and not 5 minutes, let's say 2-3 minutes, and I need to ask you guys, do you understand it or not? Is there anything in the solution of the problem that you do not understand? Please ask. Good. Okay, so let's move ahead. So this problem is done. Let's move to another problem, example 10. But it's again very simple problem. Well, ST graph is given, and what do you need? We need VT graph, AT graph. So if S is given as a function of time, S is given as a function of time, the only thing you need to do is differentiate both the equation one time, then differentiate both the equations another time. So 2 times differentiation will give you the answer. The rest of the slides for this for this PDF is something you need to go through it yourself. From here onward, we move directly towards chapter number 12, part 2. Anybody has anything to ask, you can ask. So once again, repeating, rest of the slides are not cancelled. They just, you have to cover it yourself. I mean, there's some more practice problems there. If you have any question, you can ask me later on whenever you whenever you go through the material. Okay, so let me open the next lecture, chapter number 12, part 2. If anybody has anything to ask, you can ask. Otherwise, let's have a break of 5 minutes and then we can restart back again. Is okay? Okay, Assalamu alaikum. Can you hear me? Okay, good. Let's start. Let's continue with chapter number 12. So now we are done with the rectilinear motion. Now we are going to move towards the curvilinear motion. Curvilinear motion means motion in a curve. So whenever you have a motion in a curve, that is known as curvilinear motion. So normally what happens is that it's easy to deal with the rectilinear motion, but it's quite difficult to deal with the curvilinear motion. However, there is one way. What we do is that we convert the curvilinear motion into rectangular components. Then each rectangular component we are going to deal with as a rectilinear motion. So it increases the magnitude of our problem, but the complexity is reduced because curvilinear motion itself to deal with is a bit more complicated. So what we do is that we still deal with the rectilinear motion, but how do we deal with the rectilinear motion? What we do is that we divide the curvilinear motion into rectangular components. So like for example, in the XYZ coordinate systems, what will happen is that we will we will divide the motion of the curve or the curvilinear motion into x coordinate motion, y coordinate motion, z coordinate motion. Then for each coordinate motion, we are going to deal it as a rectilinear motion. So like our problem becomes three times. The magnitude of the problem will become thrice, but the complexity is reduced back because rectilinear is simple and is easy to handle. So this is the strategy that we apply. So curvilinear motion, we divide it into rectangular components. So for example, if we have r displacement, so we'll write it as x I y j z k. X component, y component in the y direction, and the z component in the z direction. Then once you have x, y, z component, then you can find the velocities as well. If you differentiate the x, y, and z component of the displacement with respect to time, and similarly, you can find the acceleration as well. So once you have these components, you can you can resolve them back. You can join them together as well. So how can we join them together? So r will be x square plus y square plus z square under root. And similarly, once you have, for example, velocity, so velocity will have the x component. You remember x dot. X dot, I told you, what does x dot means? X dot means a differential with respect to time. Dx by dt is x dot. Dy by dt is y dot. And this is also known as vy. Dz by dt is z dot. And this is also known as vz. So these are some of the symbols that you should know. So similarly, if you have the x, y, and z component of the velocities, you can combine them together as vx square plus vy square plus vz square under root. Similarly, for the case of acceleration. Okay. Now, please have a look here. Don't get confused here. Let me just draw a rectangle here. Look here. Don't get confused here, okay? These things are same. They are different forms of representation of the same thing. So ax is the acceleration, x component of the acceleration, which is the same as vx dot, which is d by dt vx, which is the same as x double dot, which is the same as dvx by dt. Similarly, ay is same as vy dot, which is the same as y double dot, which is the same as dv by dt. Az is equals to vz dot is equals to z double dot is equals to dvz by dt. This thing, you should memorize it. You should remember it. They are different representations, but in this book they have used it interchangeably. Sometimes they use somewhere ax, sometimes they will use x double dot, sometimes they will use vx dot. But you don't get confused that, doctor, what is vx dot? You should know that these things are same. Okay, so these two lines, I'll say them. If you don't know these symbols and their representations, then just memorize them. These things are same. And when you're going to see the problems in the book, you might find that they are interchangeably used, and you might get confused if you don't know about these symbols. Is it clear? Okay, so let me just, okay, let's have a numerical. At any instant, the horizontal position of the weather balloon is defined by x is equals to 8t, where t is in seconds. So let's focus it. Okay. So this is the formula for x. If the equation of the path is y is equals to x squared by 10, determine the magnitude and direction of the velocity and acceleration when t equals to 2 seconds. So this is the problem. You're given x as a function of time, but y is not given as a function of time. Y is given as a function of x. Okay, and then you need to find what? You need to find the magnitude and direction of velocity and acceleration. Okay, so we need to find the velocity and acceleration. So if we want to find the velocity and acceleration, let's discuss about velocity. How can I find the velocity? Magnitude and direction. If I know the components of velocity, Vx and Vy, I can find then the magnitude and the direction. Okay, so Vx and Vy, how do I find Vx and Vy? Vx finding is very easy. Why? Because look here, x is given as a function of time, so just differentiate it with respect to time. So it will give you Vx. So d by dt, and just replace x as 8t, and you will get Vx. Is this thing clear or not? You need to have your hands on the laptop as well most of the time, because I need a response from you whether you are understanding or getting me or not. Anyways, let's move ahead. So this thing is clear. Now the problem will come here. X was given as a function of time, but is y also given as a function of time? No, y is given as a function of x. Now there are two ways of dealing with this problem. One way is that you just substitute the value of x in here, then y will also be as a function of time, and then you can find Vy without any problem. So this is also correct, but the book have used a second methodology. What they did is that they differentiated it in the same way as it is. So y is equals to x squared by 10. So what they did is that they use this and differentiate with respect to time. When you differentiate this with respect to time, what will happen? Some students said no. No what? Please open the mic and you can ask the question. Otherwise, I don't know what you understand or what you don't understand. Okay. Once again, I say, if you have any question, you can open the mic anytime in between and ask the question, because, you know, sometimes when you write, I don't know what really you understand, what you don't understand. So it is it is good if you want to ask any question. Don't worry to interrupt me. I don't like interruption when I'm in a direct class, but right now this is a different situation, because I really cannot see you, so I don't know whether you are getting me or not. Okay, so if you have problems, if you have issues, you can surely ask me and interrupt me. I will not mind. Okay, so anyways, so now y is not given as a function of time, so the book have used a different approach, and it says that let's differentiate with respect to time. How do you differentiate something which is not given as a function of time? How do you differentiate it with respect to time? So look here, d by dt into x squared by 10. So it will become 2x, but since it was not differential with respect to time, it becomes 2x x dot by 10. This is step. Do you understand this is step or not? This is actually not dynamics. This is mathematics. This is not dynamics. This is mathematics, but this is important here. Do you understand this is step or not? Because y was not given as a function of time. Y was given as a function of x. So once you are, so I don't know what do you call in mathematics. I think chain rule, we call it like this. So We differentiate it with respect to x, but then you have an x with respect to time differential as well. Yes, implicitly, yes. So anyways, so this is the differential for it. Now we know all other things. Why? Because we know x, okay, it's given x at this point is 16 feet. Okay, or you can also find, because we are doing it at t equals to 2 seconds. So if I put 2 here, so we'll get what is x. So we have x, then we have x dot. We have already determined x dot. Now you say when did we determine x dot? I told you x dot is the same as vx. Okay, so just substitute the values. Now you have vy. Okay, so once you have vx and vy, just substitute the values, you will get v. So vx square plus vy square under root v. And similarly, you can also get theta by tan inverse vy by vx. So we determined the magnitude and direction for the velocity. We didn't do it for acceleration yet, but we determined it for velocity. Do you understand it or not? Is there anything in this solution which you did not understand? Please ask. Clear, good. Okay, so let's move ahead. Now we need to find the magnitude and velocity of acceleration. Okay, so for Vx, it's very simple, because we have x, we one time differentiate, it becomes Vx, another time differentiate, it will become Ax. So it was, Vx was 8, another time differentiate if we do, so it will become 0. Yes, if you use the other method, this is also correct. So there's no problem if you use the other method. Okay, so Ax will be 0. Okay, and now Ay will be what? Now we have to differentiate Vy again with respect to time. So now we have 2x x dot by 10. So x dot, I don't know what kind of property do we have here. We call it associative property. I don't know. You keep one constant, differentiate the other. Then you keep the other constant, differentiate the first. So you just substitute then the values, because now we know all the things. We have x double dot. Now where is x double dot? Do we have x double dot? Yes, we have x double dot, but you don't see here because x double dot is this thing. Because x double dot is the same as vx dot, which is the same as ax. Okay, so x dot we already have. Substitute all the values, you will get ay. So once you have ax and ay, you can get a, and similarly you can get theta. So the problem is solved here. Is there anything in the solution of the problem that you do not understand? Please ask. Okay, good. So let's move ahead. Okay, for a short time, the path of the plane is described by y is equals to 0.001 x squared. If the plane is rising with a constant velocity of 10 meter per second, so let me just for a short time, the path of the plane is described by y equals to 0.001 x squared. If the plane is rising with a constant velocity of 10 meter per second, determine the magnitude of the velocity and acceleration of the plane when it is at y is equals to 100 meter. Now this is one big problem in dynamics or in engineering in general. You have a problem statement, and within the problem statement there are some key sentences, key words, which are really key to the solution of that problem, and you need to really focus over them. So here, this is one of the kind of a problem. Now read this sentence very carefully. Let me highlight it. If the plane is rising with a constant velocity of 10 meter per second. This is one sentence which looks like a very simple sentence, but it gives you some very, very key information. One key information that you get out of this is if the plane is rising. Rising means we're talking about y direction or x direction. We're talking about y direction. So if the plane is rising with a constant velocity, so velocity is constant. Since the velocity is constant, that means first information that you have is that ay is given. Okay, let me write here. Ay is given, and this is 0. This is one information. The other information is that constant velocity is given, so Vy is given, which is not 0, which is 10. Okay. So these two informations are given in this line. But you know, the information was coded. So it was not given directly that Ay is 0 and Vy is 10. It was given in the form of a sentence: if the plane is rising with a constant velocity of 10 meters per second. Now you have to decode it yourself. And this is one of the biggest problem in many problems of dynamics and in engineering in general. So you have coded sentences where you have some information and you need to decode it yourself to get the information from it. So the sentence which was coded here was, if the plane is rising with a constant velocity of 10 meters per second. And how do you decode it? Based on this statement, you come up with the fact that Ay will be 0 and Vy will be 10. Once you have decoded this information, rest of the problem is a piece of cake. Do you understand this thing or not? Okay, so if the plane is rising with a constant velocity of 10 meters per second, determine the magnitude of the velocity and acceleration of the plane when it is at y equals to 100 meter. So if you know y 100 meter, you can find what is the value of x. So now the problem becomes simple. I don't know, they initially find out the time, but the time was not needed. Okay, so we need to find Vy and Vx. Okay, so what do we have? Vy is given. Vy is given. And how can we find Vx? Because we have y as a function of x, let's differentiate it with respect to time. So it will become Vy equals to d by dt 0.001 x square, which will become 0.002 x into x dot. Now x dot is the Vx. Vy is given, so you will find Vx from here. So you have x, you have Vy. The only thing unknown is Vx. So you will find Vx. So once you have Vx and Vy, you can find magnitude of V, and you can find the direction. Is this thing clear or not? Okay, so let's move ahead. Now we need to find, again, what do we have? We have Ay. Ay was 0. Okay, so what we do is that we have the equation for Vy. So let's differentiate it again with respect to time. So equation for Ay will become 0.002 x dot Vx plus 0.002 x Vx dot. So it will become like this. Now here Ax is unknown. You already have Vx. You already have Ay. Ay is 0. Vx you just calculated. X is known. So the only thing unknown is Ax, and you can find Ax from this equation. So once you have Ax and you know Ay, you can find what is A, and you can find the other things as well. So this problem is solved. Now I'm going to wait here for, let's say, 1 or 2 minutes, and I want you to look into the problem and let me know if there is anything into it that you do not understand. Remember, my way of solution and teaching is that I will not I will not teach you how to use the calculator. The calculator, how to use the calculator is your job, your responsibility. My objective will be to focus over the main things in the problem that will hurdle you, that will constrain you from solving the problem. If you understand those small things, but they are the key things. If you understand them, then the rest of the problem is easy. You can do it without any problem. So anybody has anything to ask, please ask. Okay. When nobody's asking anything, I presume that you are understanding everything. Okay, let's move ahead. The motion of two particles A and B is described by the position vector RA and RB. We need to find the point at which the particles collide and their speed just before the collision. So it's very simple. Since they are the position vector, so when the two particles collide, they will have the same position vector. They will have the same value of the position vector. So their position should be the same when they collide. So RA should be equals to RB when this collision occurs. So we need to find uh, the point at which they collide. Okay. So we can find the point at which they collide if we make RA equals to RB. Okay. So we have this RA, so it has I component, J component, RB, I component, J component. So when we equate the two, so we have to equate the I components, we have to equate the J components. So we'll get the value of time. So let's see the solution. When you equate the X component or the I components, you get an equation, quadratic form of the equation where you have two values of time, 2 and 1 second. Then you equate the Y component of RA and RB, and you get again a quadratic equation, and again you get two values of time. One of the two values are common, so that's the actual time. So the time of collision will be 2 seconds because this is common in the solution. So once you have this time, just substitute the value of time and you will get the value of RA and RB, and that will be the position of collision which was needed in the problem. Then what else was needed? Uh, and their speed. So you also need their speed. So you need the velocity. So you have the X component and Y component. Just differentiate the X component with respect to time and the Y component with respect to time for both RA and RB. So once you differentiate this with respect to time at time t equals to 2 seconds, the VA will be this 3I minus 18J. And when you once you differentiate this RB with respect to time at time t equals to 2 seconds, it will become 6I plus 3J. So once you have these, you need to find the magnitude of the speed. So VA and VB you can get. It is 18.2 meter per second and 6.71 meter per second. I mean, this problem was actually very easy. I don't see any difficulty in the problem. If anybody feels that he do not understand any part of the solution, let me know. If things are clear to you, then let's have a break of 5 minutes. Let's give me a break of 5 minutes because continuously speaking uh, makes me tired a lot. So let's give me a break of 5 minutes and then we can start with the next topic after 5 minutes. It's okay? Okay. Okay, students, Assalamu alaikum. Can you hear me? Okay, good. So let's start back from where we stopped. Now we are moving towards the next topic. It's a continuation of the previous topic. We are discussing about the curvilinear motion. Okay. So now let's discuss about motion of a projectile. So what is a projectile? Let's first discuss about that. Projectile is motion of anything under the effect of gravity. If we have an object and that object is moving under the effect of gravity, for example, a person kick a ball. Now, once the ball is kicked, suppose there are no winds, so there are no external effects, external factors that might affect the motion of the ball. So once a person kick a ball, then the ball will move purely under the effect of gravity. And what kind of motion of the ball will be? It will not be a straight line motion, it will be a curvilinear motion. The motion would be in a curve. So the ball will continue move up, and as well as it continues to move far away. And then after that, once it reached a maximum height, then it starts moving down and until it reached the ground and hit back on the ground. So this kind of motion is known as a projectile motion. So what is a projectile motion? A projectile motion is the motion of anything, any body, under the effect of gravity only, no other factors, just the factor of gravity is there. Then that kind of motion is known as projectile motion. Is it clear? So one thing is very clear, that the projectile motion, the one thing is very clear, that a projectile motion is a curvilinear motion. So we're talking about the motion in, let's say, we are not talking about three-dimensional motion. Let's say on a two-dimensional plane, the motion will be in the X and Y direction. And since the motion is in the X and Y direction, there is gravity acting on the body. So the gravity will not act in the X direction. The gravity will act in the Y direction. Okay. So the gravity will not act in the X direction. The gravity will act in the Y direction. Suppose if we say that positive X direction is, this is the positive X direction, and the positive Y direction is upward. So what do you think? The gravity is acting in the upward direction or the downward direction? Basically, the gravity is always pulling things towards the earth. So it will act in the downward direction. Okay. So the gravity is acting in the downward direction. Now, since we are talking about the motion of a projectile, so projectile, as I told you, is a motion of any object under the effect of gravity, and the gravity is only acting in the Y direction. And gravity is basically what? Do you know the unit of gravity? 9.81 meter per second square. That's the unit of acceleration. So gravity is kind of acceleration. It's actually acceleration. Okay. So the force of gravity is basically the acceleration which a body faces as it moves within the atmosphere. So the gravity is so there is acceleration over a body in the Y direction, but is there any acceleration in the X direction during a projectile motion? Purely projectile motion means effect of gravity only. So there is no acceleration in the X direction. There is only acceleration in the Y direction, and the acceleration in the Y direction is in the negative Y direction. Okay, so now let's go back to the equations that we developed before. Okay, so let's go back to those equations. So if you remember, these were the 10 equations that we developed. Equation 1, 2, 3, 4, 5, 6. But 1, 2, 3, 4, 5, 6 does not have acceleration constant. Gravity is a constant acceleration. So 1, 2, 3, 4, 5, 6 are not applicable here. So what are applicable here? Here applicable are equations 7, 8, 9, and 10. these equations are applicable. Now let's have a look at it. How does the application work? First of all, when we are talking about the projectile motion, so we have the constant acceleration, and I will write here as negative g. Why negative? Because it is in the negative y direction. Okay. So as I told you, projectile is a curvilinear motion. So curvilinear motion means we need to divide it into x and y coordinates. Okay, we need to divide it into x and y components. Let's say if we divide it into x and y components, in the x component, is there any acceleration in the x component? No. So we will say that in the x direction, there is no acceleration in the x direction. And since there is no acceleration in the x direction, so we can have only equation 10, which is valid for the x direction, because when we have the constant acceleration equals to 0. So equation 10 is valid when constant acceleration is equals to 0. So for a projectile motion in x direction, we can have only equation 10 valid. So x component from equation 10, s is equals to v naught t. Here I can put s because s is the distance. Here I can put s as x because it's the distance in the x direction. And v naught should be v naught x because we're talking everything in the x component direction. So initial velocity in the x direction multiply by the time. This would be my equation number 11, but this is basically from equation number 10 for a projectile motion in x component. Okay, now for the y component of the projectile motion, all the three equations, because we have a constant acceleration which is ac equals to negative g, so all the above three equations, equation number 9, 8 and 7 are applicable. So let's see how they would look like. Equation number 7, v equals to v naught plus act, it will become vy is equals to v naught y, because it's a y component, minus gt. Let's see equation number 8. It was s is equals to s naught plus v naught t plus half act square. For projectile motion, it will become y, because s is the distance. So y equals to y naught, initial distance. I mean, let's say normally we can normally put y naught as 0. That's the initial position. Plus v naught y t minus half gt square. So that will be equation 13. Now let's talk about equation number 14. V square equals to v naught square plus 2ac s minus s naught. So how would it be in the projectile motion? It will be vy square equals to v naught y square minus 2g y minus y naught. That will be equation number 14. So we got equation number 11, 12, 13, and 14 for the projectile motion, where equation number 11 is derived from equation 10, and 12, 13, and 14 is derived from equation number 7, 8, and 9 for the projectile motion. Okay, do you understand these four equations or not? Or not? Equation number 11, 12, 13, 14. Is anybody among the students who do not understand any one of the equation? Please feel free to ask. You can open your mic if you want to ask the question. Good. If you understand equation 7, 8, 9, 10, then equation 11, 12, 13, 14 understanding is not a problem at all. They're simple. Okay. So now you have these equations, but remember one thing, equation 11 is applicable in the x direction only. If any of the student put equation 11 for y component of the projectile motion, that is a mistake. Equation number 12, 13, and 14 is only applicable for y direction. If any of the student do the mistake that for the x component used equation 12, 13, or 14, that is a mistake. So you need to understand which equation to use where. If you misuse any equation and any other situation, it will be considered a mistake. Is it clear? Okay. Now there are some other points you should understand. If particle is moving up from reference point, you always have a start point, you always have an end point. If the particle is moving up from the reference point, then y is positive. If the particle is moving down from the reference point, then the y is negative. So reference point means the starting point where the motion is started. Okay, v naught is always the starting velocity. Okay, v is the final velocity, and t is the time to move between v naught to v. So v naught is the starting velocity, v is the final velocity, and t is the time to move between v naught to v. Now, just considering all these things, we are going to start solving problems, inshallah, for the projectile motion, and inshallah, the problem solution will not be that difficult. Anybody has any question regarding this? This page is, by the way, also uploaded there. I uploaded one supplementary file page, but then I updated it just before the lecture. So now this page is also there on the Google Drive. Okay, so let me put it here because I need to use it again and again. So the four equations are visible. Equation number 11, 12, 13, 14. Okay, let's come here. Now I have minimized the chat box. So if you write anything in the chat box, I don't know. If you want to ask any question, just raise your voice and ask, because if I open the chat box, I cannot see this page. I need this page here. This is all the description written. I don't need to go with you with these descriptions. I have already explained you everything needed to be explained. So let's have the problem. What is given? A person is kicking a ball. A person is kicking a ball at point A, and the ball will strike the ground at point C. Okay, so what is given is VA and theta. So the velocity with which the ball is hit, 10 meters per second, that is given. And the theta, the angle at which the ball was hit, that theta is given. So theta is 30 degree, and VA is 10 meters per second. These two things are given. What do we need to find? Find the horizontal distance it traveled and the VC. So we need to find this. How much is this horizontal distance? Okay, and at this point, whatever the velocity VC, how much is VC? This is what we need to find. Do you understand the problem statement? We have a person kicking the ball. The velocity of the hit is 10 meters per second. The theta at which the ball was hit was 30 degree. What do we need to find? How far did the ball move? Okay. So, and the other thing that we need to find is what is the final velocity of the ball. So we have four equations in front of us. This is the projectile motion. So let's see how to use the four equations. The first equation is, we can use here, because we have VA. So first thing is that we need to find VAX and VAY. So the initial velocity in the X direction, initial velocity in the Y direction, we should know. Okay. So first we will find from VA, we find VAX and VAY. So this is VAX, this will be VAY. So we have initial velocities in the X and Y direction. This is what we know. Now, what do we need? We need X. This is the distance, right? We need X. And initial velocity in the X direction, we already have it. This is Vax, initial velocity in the x direction. Do we have the time? No, we don't have the time. Okay, so if we get the time, we will substitute in this equation and we will get what is x. Okay, so now let's apply for the y direction. For the y direction, we can apply this equation. Do we know the final velocity? No, the final velocity in y direction we don't know. Okay, do we know initial velocity in y direction? Yes, we know. Do we know g? Yes, we know. Do we know time? No, we don't know time. Okay, let's see equation 13. Why not? We can put it as 0. This we can put it as 0. So do we know y? Now you see here, y is basically what? What is the distance traveled from start point to the end point? Start point was on the ground. End point is also on the ground. Point A is on the ground. Point C is on the ground. So y distance between A and C is 0. So yes, we know y. This is 0. Okay, because A is also on the ground and C is also on the ground. A is the start point, C is the end point. So we know y. Do we not y? Yes, we know y is known. We know g. Only time is unknown. So this is best equation. In this equation, only time is unknown and we can find the time. Once you have the time, you can substitute the time here and you can find x. Once you have the time, you can substitute the time here and you will find Vy. Vy is the final velocity, the component of final velocity in the y direction. The component of, okay, in the x direction, the velocity will not change. Why? Because the acceleration is 0. So whatever the initial velocity in the x direction is the same as the final velocity in the x direction. So Vcx will be the same as Vax. Vcy you will get from here once you know the time. So you just substitute the values and you solve the problem. Actually, the problem is solved there. Do you understand the problem solution or not? Please open your mic if you don't understand. As I told you, my objective will be, the equations will be in front of you, okay? And I will be looking at what is given, what is needed, and how the problem should proceed. Now, once, for example, the equation is here with only one unknown, so khalas, now it's your duty how to get the value. It's now no more dynamics, it's mathematics. And how to use the calculator, this is also not my job. You should be able to know how to use the calculator. So this way I have solved this problem in front of you. The solution is there in the lecture slides as well. But anyways, I have looked the problem the way I should look it. Now, if anybody don't understand anything, once again, I'm asking, you're free to ask.
Doctor,
Yes.
is VC here mean VCY or the magnitude of VCY and VCX?
Okay, your question is that when it is asked in the question, what does VC means? It means the VC magnitude. That means VCX component and VCY component combined together. So that means VCX square plus VCY square under root when it is asked in the question. Okay, so but you have to solve it independently, right? So for the x component, you know that for Vax would be the same as VCX. Since you know Va and you can find Vax, so that would be the same as VCX. What about VCY? VCY, you have to use equation 12, 13, and 14. So for equation 12 will give you VCY. Okay, but you need time. So first you need to solve equation 13, so you get time, and then you substitute the time here, you will get VCY. So once you have VCY and you know VCX, then you're going to combine them together to get VC. Did I answer your question?
Yes, thank you.
Okay. Anyone else? Okay, so let me rub it. So you see here, first they made up the equation, then put y equals to 0, find out the time. Okay, once you have the time, then you can substitute into the main equation to get vcy, and also you can substitute in the equation here, x is equals to v naught xt to get the distance. Next problem. A projectile is fired with a velocity 150 meter per second at point A. This is point A. Okay, this projectile is fired 150 meter per second. That was the initial velocity. What is the angle? Angle is not given, but what is given? You see here a small triangle like this is given. It says 5, 3, 4. Okay, so can you use this triangle to find out the x component and y component? I'm sure you can. Okay, so we use this thing to find VAX and VAY, which is the initial velocity in the x direction and y direction. Okay, what do we need? Find the horizontal distance it travel. Again, this R is asked. This R is basically what? This R is the same as this X. This is needed. Okay, this is known. This, if you know this time, then you can find this. Okay, now how do you solve it? You move towards the y component equations. For the y component equation, again, the first equation Vy, but we don't know Vy, and it is also not needed. What is needed is time and the horizontal distance. So let's leave this equation. Let's not use this one. Rather, let's use this one. Y naught is 0. Okay, tell me why. You see here, as I told you, if the object is moving downward from the reference, so our reference is point A, that's the starting point. Point B is not above the A, point B is below A. So A elevation is this, B is below A. Okay, and how much below A? 150 meter. So in this case, we know our Y. Our Y is from start to the end point. It is 150 meter, but negative. But negative. Why? Because B is below A. Okay, so we know our Y. V naught Y. We know V naught Y because initial velocity we know. Time we don't know. G we know. So we know everything except time. So we will find what is time. And once we have time, we will substitute the time here to get what is R. Is it clear or not? Clear. Good. So this is important point. I wrote there on my page as well. That remember, look at the position of the final position with respect to the reference, with respect to initial position. Is it up or down? If it is up, then positive. If it is down, then y will be negative. Here in this case, y will be negative. Why? Because B is down than A. Okay. So let's have a look at the solution here. So we have this is the main equation we use here. Okay, then you see here YB is negative 150. This is what I was saying to you. So negative 150. Y would be negative here. Why not? We can put 0. And so we get the time. Once we have the time, we will get the distance. It's not difficult. Just you have to use it in the right way. Okay, let's move towards the next problem. Okay, a sack slides off the ramp shown in the figure with a horizontal velocity 12 meter per second. If the height of the ramp is 6 meters from the floor, determine the time needed for the sack to strike the floor and the range where the sack begins to pile up. Once again, what do we need to find? We need to find the range. This is, so that's the x. Okay. You see here, sack slides off the ramp with a horizontal velocity. So this 12 meter per second is basically what? It's a horizontal velocity. Horizontal velocity means VAX initial, and VAY is 0 because the sack was moving horizontally. So VAY is 0. So we have VAX, VAY is 0. If the height of the ramp is 6 meter, so this is 6 meter, so our Y will be -6. You get it? From start to the end point, it's going down. So Y will be -6. So we need to find the time needed and we need to find the range. Then rest of the problem is the same as before. So you have this thing, okay, you will use this equation. You have Y, you have V naught Y is 0. This is 0. Okay, so this is also considered 0. Y naught. Then you have G, you'll find time, substitute the time here, you'll find X. It's clear? Yes. Vx is, yeah, Vx is 12 meter per second. Anybody has anything to ask? You can see the solution here. You see, YB is -6. I told you. Okay. And then this term is also 0 because VFI is 0. VFI is 0. Substitute all the values, you get the time. Substitute here, you get the range. Okay, this problem, you can see this problem yourself. Okay, no difficulty in it. Okay, let's solve this because all the problems are similar in nature actually. A chipping machine is designed to eject wood chips at V naught equals to 25 feet per second as shown in the figure. So initial velocity is, this is given, 25 feet per second, and angle is 30 degree. If the tube is oriented at 30 degree from the horizontal, determine how high the chips strike the pile if at this instant they land on the pile 20 feet from the table, 20 feet from the tube. Okay, so this is what we need to find out. We need to find out this height. Okay, so we have the initial velocity, we have the angle, so we have the V naught x, we have the V naught y. Okay, so V naught x is something known. In this case here, it is also given that this is 20 feet. So x is also given. This will be 20 feet. So you can find the time directly. Okay. Then what is needed? We need to find this height. For finding this height, if we find this one. If we find this height, then the total is 4. So subtract this from 4, you will get this height. You get it? So we can find this height by using this equation. This y will give us this height. Okay. So we know the initial velocity. Let's put this as 0. Okay. Now we know the time. Khalas, we can find out what is y. And this y will be this. So this plus h is 4. So if you know this, and if you know this is 4, you can find what is h. Is it clear or not? So just keep some of the things in mind, that you have to use equation number 11 for the x direction, for the x component for projectile motion. If you use equation number 11 for y component, that will be a big mistake. Second point, you have to use equation number 12, 13, and 14 for the y components. If you use 12, 13, and 14 for x component, that will be a big mistake. Okay. And what else, just that always keep a look at the reference point. Where is your reference point? Okay, and based on your reference point, you can find, you can use this equation 12, 13, and 14. I mean, it's not necessary I have been using equation 13 all the time, but suppose if you don't want to use 13, suppose you want to use 12 and equation 14, and somehow you can solve the problem by using these two equations, no problem. They all are applicable in the y direction for projectile motion, and you can use any one of them. In equation number 14, there is no time factor. Suppose you need to solve a problem where time is not used, you don't want time, then you can solve it using equation number 14. So anyways, at this point onward, I will say that rest of the material, you go through it yourself in these slides. So chapter number 12 part 1 and part 2 are both finished, although chapter number 12 is not completed, because the one where I have given the heading chapter number 13, initial part of chapter number 13 is also actually chapter number 12. So that one topic we will cover, but we will cover it when we will be covering chapter number 13. So at this point onward, I will say here that chapter number 12, except for that one topic which is there in chapter number 13 slide, is finished. So anybody want to ask anything, you can ask. Okay, if nobody has anything to ask, then our lecture today is finished. And we will have the lecture inshallah next week now. We will start chapter number 13 slide. Okay. If you want to leave, you can leave.